Assalamualaikum. This is, my name is Anam Javed and my registration number is 16T82. This is the fifth lecture of digital signal processing. In today's lecture, we are going to cover the following topics. Number one topic is the basic operation on a system. The basic operations that are being applied on a system are number one is shifting, number two is flipping, mirror or inverse, and the number three is scaling. Two types of scaling are involved: index scaling and amplitude scaling. The second main topic is impulse response. Now, how to find impulse response and how we can construct an arbitrary signal using impulse signals or impulse responses. Now, let's consider a system. This is given a system that is y of n equals to x of minus 2 plus n, and the input values, that is x of n equals to 1, 2, minus 1, 2, 0, 1, 1 and 3. This underline indicates the zero index, means at 0 its value is minus 1. Now we are going to apply the following operations, basic operations that I have previously explained. Number one is shifting. We will shift the system according to the equation. Plus 3 indicates a shift of 3 times shift. So we can write it as x of n plus 3, means the system is shifted 3 times. There is a shift of 3 values, so 0 index is shifted 3 times of its current position, means if currently 0 index is here, it is shifted 3 times, 1, 2 and 3, means now this 1 will become our 0 index, like this. Previously it was here, now 0 index is shifted 3 times and this is our new 0 index. The second basic operation is flipping, or the mirror or inverse of the system. We have taken another system, that is w of n equals to u of minus n. In the above given system, the flipping or mirror images that is being applied is minus of n, means we are going to reverse or flip the values around the 0 index that we have previously calculated. Flipping the values around the 0 index as shown, means 1, 3 is on the right, then they both will come here on the left and these values will appear on the right of the 0 index. Or simply you can write it in reverse direction like this. So we will obtain this system. Third basic operation is scaling. The scaling that is applied here is w2 of n, that is y of n equals to w2 of n. The system is being multiplied with 2. This is means compression. In previous lecture I have explained compression, that is when a constant is being multiplied, the system is compressed 2 times, means before and after values of 0 index are compressed 2 times. This is our 0 index, this is, sorry, we have to consider this system. This is our 0 index, this is 1, 2, 3, 4, 5, and this is minus 1, this is minus 2, that is on the left of the 0 index. Now we have to compress this 2 times, means we have to consider the second value before and after of the 0 index. This is 0 index 1 and 2, means this is going to be included in our output here. Now again counting from here, we have to compress it 2 times, so 1, 2, means this 2 is again going to be included in the output. Now again counting from 1 and 2, because we have to compress this 2 times, 1 and 2, the other value doesn't exist, so this is discarded, we don't consider it. Same procedure will apply on the left. Starting from the 0 index, we have to compress it 2 times, so we will count 2 times. 1 and 2 means this 3 is going to be included in the output signal, and finally this is our 0 index. Hence this is scaled, and that is an example of compression. 3 basic operations are being applied on a system. The next thing is how to find a system when input and output graphs are given. Means previously we are given with the system and its input values, and we are finding or we're calculating its basic operation that are being involved in it. Now if we are provided with the graphs, input and output graphs, how can we find the system through which the input is being passed and after processing it will provide the output? This is x of n, that is input graph, and this is y of n, that is output graph. Now we have to find the system response, that is the system, how the system look like. The major question is we are provided with input, that is y of n, and output, that is input as x of n and output as y of n, and we have to find the system. We will see it further how we can find x of n graph is given, and if we put x of n minus 1, that is the delayed version, equals to 0, the value of n comes out to be 1. That is, we have to shift the original input signal by 1 as shown here. How have we shifted it? I will show you. This is our input signal, that is x of n. We have to shift it 1 time, means -3 plus 1 is -2, so we will get an impulse on -2 here. -2 plus 1 is -1, so we will get an impulse on -1. Why we are adding 1? Because we are shifting it 1 time. On 0 it will 0. On 0 it will 1, because 0 plus 1 is 1. On 1 it is 0, and we have to shift it 1 time. 1 plus 1 is 2, so we will get an impulse on 2. Similarly for 3 and 4, this is the shifted version of the original signal, that is x of n minus 1. Now what we have to do, the next step is to take this difference, that is x of n minus 1. Previous state and the present state, that is current value minus the previous value. This is the simplest system, and we are going to take its difference. The output will look like this. How it is constructed, I will explain you. Consider the original input signal, that is x of n. Here on -3 there is value 1, and here in the shifted version of x of n, that is x of n minus 1, the value at -3 is 0. 1 minus 0 is 1, so we will get an impulse on -3, that is equals to 1. On -2 there is an impulse, and on -2 there is an impulse of equal amplitude, -2. They both will cancel out, and amplitude we get is 0. -1 is 0, 0 minus 1 is -1, so we'll get an impulse on -1. 0 minus 0 is 0, so here this is 0. 0 minus 1 is -1, so we will get an impulse on -1. 1 minus 0 is 1, so we will get an impulse on 2, that is 1. 1 minus 1 is 0, so we'll get a 0 over here. On 4 we have 0 minus 1 is minus 1, so we'll get an impulse of minus 1 over here. We have seen how we can find the system when input and output graph are given. We just have shifted it one time, and then by taking its difference we have easily identified the system, that is it is equals to y of n equals to x of n minus x of n minus 1, that is current value minus the previous value. Now the second topic is our impulse response. What is impulse response? Impulse response is basically known when an input is fed, the input must be an impulse. When it is fed to a system, it is being processed, and the response that it will provide after processing is known as the impulse response. As this indicates, delta of n is applied to a system, and the response h of n is known as its impulse response. Hence, h of n is the impulse response of the system. Now let's look at the example. Y of n equals to x of n minus x of n minus 1, and the input set is given, that is 2, 3 and minus 1. Minus 1 here is the 0 index. As we are going to calculate the impulse response, so we are taking y of n equals to delta of n. Rewriting the system, that is this, into delta form by simply replacing x by delta. Now by varying the value of n, we are going to find the impulse response. Here n equals to 0, delta of 0 minus delta of n minus 1, n equals to 0, so here it will become minus 1. As we know, the most important thing is delta of 0 equals to 1. So this is 1 and this will give 0. 1 minus 0 is 1. Next step is we are going to put n equals to 1. This will become delta of 1 minus delta of 0. As this is given, delta of 0 is 1 and delta of 1 is 0. 0 minus 1 is minus 1. Now in the next step, we are taking the value of n equals to 2. This will become delta of 2 minus delta of 1. As delta signal is only 1 when n equals to 0. Here both are greater than 1. For all the other values of n rather than 0, it will give 0. So it will become 0. Similarly, for n equals to 3, it will become delta of 3 and delta of 2. As I have told you that impulse response is only 1 when n equals to 0, and it is 0 for all the other values of n. So it will also give 0 in return. The system we get after applying the impulse response is at 0 index it is minus 1, at 1 it is minus 1, and it is 0 for all the other values. Now the second thing that is being involved in the impulse response is the construction of arbitrary function using delayed and the shifted impulse signals. This is again given an input set. At 0 index the value of x of n is 3, at minus 1 index it is equals to 2, and at index 1 it is equals to minus 1. Now rewriting it in delta form, if index is minus 1, that it means there is a shift of plus 1, and at 0 it is delta of n, and at 1 it is delta of n minus 1. Let me correct here, there is a mistake. this should be n minus 1. This should be n minus 1. The next step is when we put our delta equals to 0, means at 0 index its value is 3. So we have to multiply it with 3 as delta of 0 equals to 1. So 1 into 3 is 3, means we will get an impulse of amplitude 3 at n equals to 0. N equals to 0, an impulse of amplitude 3. The next step is delta of n minus 1. From where this n minus 1 came? From this index value. When index is 1, its delta response is written as delta of n minus 1. This positive 1 is being shifted and indicating a shift of minus 1. At index 1, its value is minus 1, so it is multiplied with minus 1 and giving an answer of minus 1. That means n minus 1 equals to 0, n equals to 1, means we are going to get an impulse of minus 1 at n equals to 1, like this. The third step is delta of n plus 1. From where this delta n plus 1 came? It came from here. Delta n plus 1 indicates the minus 1 index. When index is minus 1, its delta form is written as delta of n plus 1. This delta of n plus 1 is multiplied with 2. Why? Because at minus 1 index its value is 2. So how can we find the impulse where we are going to get an impulse? We are going to put this n plus 1 equals to 0, like this. N plus 1 equals to 0 and n equals to minus 1, means at minus 1 we will get an impulse of amplitude 2. Minus 1 amplitude of 2. Now the third step is to add all these impulses that we have calculated. At 0 it's 3, simply drawing the spikes. 0 at 0 it's 3, and at minus 1 it is 2. So by simply drawing minus 1 equals to 2, and here 1 at 1 its amplitude is minus 1. This is how we can calculate an arbitrary function by using the delayed and shifted impulse response. By involving the indexes and its value, we can construct or we can find any arbitrary function. This is all about lecture number 5. Thank you for watching.